Okay, the second part of this recording is section S9I Where Functions Meet. Okay, so it starts at this page here. So if I've got a curve and a straight line, um, they're either going to intersect at two spots, at one spot, or not intersecting at all. Okay, when it intersects at one spot, this is called a tangent point. That name will be important um, when you take calculus next year. Okay, and this is intersecting at 2 points. Okay, so find the coordinates of the point of intersection with the graphs with the equation here and this equation. So if we're trying to find out points of intersection, basically you can make the two equations equal to each other. So we're going to do that without using technology. So basically what we're going to do is we're going to make these two equations equal to each other. Then after I've done that, I can see we want to get everything onto one side of the equation. So I'm going to subtract x on both sides of the equation to make that cancel out, and I'm going to add 3 onto both sides of the equation to make that cancel out. So then I've got x squared and negative x gives me negative 2x, and 18 plus 3 is going to give me negative 18 plus 3 gives me negative 15 equals 0, and then I go back to my factoring handout and say, okay, what two things multiply to give me 15 and subtract to give me 2, and you know that that's going to be 5 and 3. So I have x minus 5 times x plus 3. So my two x values, it's going to be intersecting at 2 points. My two x values are going to be 5 and negative 3. So now I'm going to plug in 5 and negative 3 into one of these two equations. Well, I decided to pick the linear equation. That's a little easier. You'll still get the same y answer. So if I plug 5 in place of x, then I end up with 5 minus 3, which gives me 2. If I plug in negative 3 in for x, we get negative 3 minus negative 3, which gives me negative 6. So the coordinates of the two coordinates where my curve intersects the line are 5, 2 and negative 3, 6. All right? So here are the answers for the next part. You might want to hit pause. And for question D, in class we decided to skip this one. You end up, it doesn't factor out nicely like these all do. So I told you guys to just skip this one here. The answer comes out to be a decimal, and you would be easier to do it with a calculator, which we'll explain on the next page. And on this question C, it's interesting because we end up with x minus 3 times x minus 3. So it means we're going to have just 1 point touching. So this one is more like this example here where the curve touches the line in 1 point. Okay, you may want to hit pause to check your work. All right, next one. So in this example, you've got two curves. Okay, and they want you to solve this using your calculator. So the very first thing you need to do is you need to hit y equals, and then type in your equation. So y1 equals this, and y2 equals this. Okay, now when you type them in, okay, so let's do that here on my calculator here. Okay, so x squared plus 5x plus 6, and then here I type in 2x squared plus 2x minus 4. All right. So if I want to see how these look, I can hit Graph. Now, look, it doesn't quite meet up here. I need to change the window, and your window may look totally different. If you hit Zoom 6, that gets you a standard 10 by 10 window, which definitely is not good enough to see here. Now, on the sheet here, I told you what the uh, window parameters are. So you can probably leave your X uh, parameters here. To change them, you hit uh, window, and then it changes the access boundaries here. So -10 here and 10 here, that's probably okay. Now the bottom here, I'm going to make that probably, let's make that -10. So my Y min, I'm going to make that to -10. Okay, that's fine. And then here I'm going to make the max 60. And then if I graph that, you should see the intersection in two spots. So right there and up here. Okay, so so to find out where they intersect, I'm going to talk about how to draw the graph in just a second. But to figure out where they intersect, I'm going to hit second trace, enter at where it says 5 intersect, and then we just talked about how to adjust the window, and then you're going to hit the arrows over to get them close to the intersection, and hit enter 3 times, and these are the values you're going to get. Now I'm going to show you how to get this in just a second. You may want to copy the. You may want to hit pause and copy these instructions right now. Okay, so let's get one of these intersections. So what's the step? Second trace. So hit second trace, and then I'm going to go down to 5 intersect, right? 5 intersect. And now it says first curve. And notice how it's blinking over here. So I want it to get blinking over here at this curve. So I'm going to arrow over. Notice how I'm hitting the left arrow. I'm getting it close to it. That's close enough. And now I'm going to hit enter 3 times. 1, 2, 3. And it tells me that intersection is -2, 0. So this point right here is -2, 0. Okay. I'm going to go through the steps again. Second trace. I'm going to arrow down to 5 intersect, and I hit enter. Now I'm going to hit the right arrow until I get close to the other intersection of the two curves. Okay, I'm pretty close to the intersection of the other two curves. I'm going to hit enter 3 times. And now it tells me this intersection is 5, 56. Okay. Now, how did I get, notice here I found some interesting points here, and I was able to graph this. So how do I get those points? So you can go to second graph to get a table. Now, let's talk about which points I'm going to use. So notice here when x is 0, let's just start off with 0. When x is 0, y1 is 6. So if I go to 0, 6, that gives me this point on the blue line. When x is 1, y1 is 12. So I go over to 1, I'm going to go up to 12. Okay. When x is 2, y1 is 20. So I go here 2, I go up to 20. So you can see this y-axis represents the blue line here. When x is 3, y is 30. When x is 4, y is 42. And so on. When x is 5, y is 56. It's up here. And then if I want the red line here, I do when x is 0, y is -4. When x is 1, y is 0. When x is 2, y is 8. And you can see where I'm getting these points from. When x is 3, y is 20, and so on. Now question B says solve when this graph here is greater than that graph here. So this graph here is the blue one, and this graph here is the red one. So the blue one is greater than the other graph when the blue one is higher than that graph. So between these 2 points, between -2 and 5, with the domain of -2 and 5, that's when the blue graph is above the red graph. Okay, so for questions 2A and B, you may want to check your answers. Okay, now let's go to the next page. Okay, at a school sports day, Petra has thrown a shot put, and the path of the shot put follows a parabolic curve with this equation, where t represents time in seconds, and that has elapsed in the shot put. Since the shot put was put in the left Petra's hand, and f of t is the height of the shot put in meters above the ground. Okay, so this here is time, and this here is height. Okay, so let's type in this equation. So 1.75 plus 0.75 x minus 0.0625 x squared. Okay. And if I hit graph, okay, well clearly this window isn't set right. So fortunately, I already gave you what the min and maxes of each should be. So I go to hit window, and my x min, -10 is fine. X max, we should make that to 20. Y max, let's make that 10. And y min 10 sounds fine. So now I can hit graph, and it's going to look pretty good. Okay. So once again, if I want to figure out a good table, I can hit second graph to get a table, and we can plot some points here. So when x is 0, y is 1.75. That's kind of right around there. Let's get the integer points first. When x is 2, y is 3. When x is 6, y is 4. When x is -2, y is 0. When x is -6, y is -5. When x is 10, y is 3. When x is, 14, y was 0. Is that right? And when x is 18, y is -5. Okay. So with this information, you can see that it's kind of making this kind of a curve, right? So second graph to get a table really works well. Okay. So second graph to get a table works really well. And you can adjust the table by hitting second window and change the delta TBL to 1 and the delta start to 1. You may want to hit pause for a second. Okay, so this part right here, let's see what am I talking about. So if I hit second window, I can change the delta TBL to, let's just change it to 0. And then this delta TBL, leave it at 1. Then I can do second graph to look at my table, and notice it starts at 0. So if I wanted it to go by half increments, I could type in 0.5 and then second graph, and notice it goes 0, 0.5, 1, 1.5, and so on. But right now, for this problem, we're just having it go up by integers. Okay, so delta TBL of 1, that started at 0. Okay. So, question A, find the height of the shot put after 5 seconds. So I'm going to plug in 5 in for the time, and then we figure out the height after 5 seconds. Question B, find the time when the height of the shot put is 3 meters. So what I've done is I'm going to set an equation equal to 3. So if I go here, I'm going to make another line and make this equal to 3. And now we're going to have a horizontal line cut the parabola here when y equals 3. Okay. So if I want to figure out where these two meet when y equals 3, I need to figure out the intersection. So how do I figure out the intersection? You hit second trace, and we're going to figure out the intersection, so 5. And then I'm going to arrow to the left, get close to that intersection right there. I hit enter, 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 and this intersection is at 2, 3. See? Okay, and then I'm going to go through the process again, second trace, and I'm going to go 5, intersect, and I'm going to arrow over to the other intersection, over here, hit enter, 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 and this intersection is 10, 3. And these are the 2 points, the 2 times when the height of the shot put is at 3 meters high. Okay, go through the same process, and here are the answers for 2 and 3.